Hello, and welcome to our Consulting Specifying Engineer conversation. I'm your host, Amara Rozgus, and today I'm speaking with Joseph Guerin from Trane. Hey, Joe, how are you?
I'm good. Thanks for having me.
Yeah. Thanks for connecting today. Before we get to the details on refrigerants and the VRF market, let me provide some background information about Joe. Joseph Guerin is Trane's Mid-Atlantic VRF ductless sales specialist. In his current role, Joe is primarily responsible for overseeing and supporting the design and application of commercial VRF projects in the region. He focuses on plan and spec project design, working closely with consulting engineers and consultants in Baltimore, Harrisburg, and northeastern Pennsylvania. With more than 10 years of experience in Trane commercial, Joe has focused on systems design, applications, and sales. As an active ASHRAE member, he has taken a keen interest in the 2022 update of ASHRAE 15 safety standard, exploring its implications for VRF and ductless system design. A lot to cover here today, Joe. Can you give me an overview of your role as a ductless sales specialist with the Mid-Atlantic region?
Yeah, I think you covered it pretty well in the summary there. And I like to say I'm almost like the guardrails, when you go bowling. So I'm there to support engineers and contractors who have a vision for what they want to do with VRF, but to make sure that we are doing it within the equipment's capabilities, and we're doing it in the most efficient and cost-effective manner possible. The genesis for this call, what we're going to talk a lot about is the newest wrinkle in all of that is the 410A phase down, equipment availability, EPA deadlines, et cetera. So that's been an interesting little wrinkle that's been thrown into the industry the last year and a half.
Definitely a hot topic. The industry is transitioning to low global warming potential refrigerants. So are building codes and safety standards like ASHRAE 15 evolving to accommodate these new A2L refrigerants in VRF applications?
Yes, yeah, and it's been quite a ride. So I guess a quick summary of how it all fits together. ASHRAE 15 is the tip of the spear. All right, so that's the safety standard, and they outline how to safely apply refrigeration systems. And it's product agnostic. I'm running piping here, I'm using this kind of cooling and heating, et cetera. How do we put that into a building, but maintain occupant safety? So ASHRAE 15 writes those guidelines. They get adopted into building codes, and then building codes eventually get adopted by local states and municipalities. So like I said, ASHRAE 15 is the tip of the spear. And I always like to draw the comparison. The 2019 version of ASHRAE 15 was, I think it was like 50 pages long. And then in 2022, when they added, here's how to design with A2L refrigerants, it went up to over 150 pages long. So a lot of updates. And again, we're still at the ASHRAE 15 stage, but codes and states are also keenly keeping an eye on it because A2Ls are getting installed today, and for VRF, going to be installed very soon.
Okay, thank you for that explanation. How do you anticipate the use of A2L refrigerants? How's it going to influence VRF system design in the future?
Yeah, there's a lot that went into the safety standard. I always like to ask, and I'll ask you this question, Amara, if just for kicks and giggles here. Guess how many times ASHRAE 15 mentions VRF for variable refrigerant flow?
Oh, several.
It's zero.
Zero. Okay, even
It's
better.
zero. Yeah. So again, it's product agnostic, but so you have to go through and kind of dissect. All right, what are we talking about here when they say this, when they say this? And if you dissect all of it, and I will say that they did a great job laying it out. It wasn't too bad. But what we're going to have to look out for VRF is where are we running piping? Do we have leak detection? for refrigerant leaks? Do we have a means of circulating air in a space? Because when refrigerant leaks, we don't want it concentrating. If it concentrates, it can ignite. So we want to kick it up and spread it over as much cubic feet as possible. Mitigation controls is a new item where if we sense a leak, we can isolate a unit. And refrigerant pipe shafts, that's another big consideration, because shafts are like an artery in a building for a building fire. So being cognizant of, hey, what are we putting in that shaft? If it's slightly flammable, what do we have to do to ensure occupant safety? So it's a lot of considerations, but it's not impossible. It's not too bad.
Perfect segue to my next question. Leak detection, safety shutoff valves, those are likely becoming standard components in VRF equipment. How do you foresee this impacting not only safety and code compliance, but also system reliability or diagnostics, or even just peace of mind for the owners and occupants?
Yeah, the thing with VRF, it's a very refrigerant intensive system. There's a lot of refrigerant per ton of cooling compared to most other HVAC systems. So there's always been a little misgiving with VRF. Oh, we've got all this refrigerant pulsing through a building. VRF's really efficient. It's beautiful, but that's the misgiving, right? Is I've got hundreds of pounds of refrigerant with this thing. Now in the past, with A1s and VRF being new, that concern's died down a lot, right? Contractors now install great VRF systems. They know what to look out for. So that concern's gone down over time. But owners now, I think you've got something great coming with this new generation of equipment, right? If you had misgivings before, you shouldn't have them anymore, because now we've got leak detectors and mitigation controls to mitigate those leaks. The other great thing for installers or contractors, when there was a leak, all right, you didn't get notified of it. You found out because your system was low on charge, or you saw a stain in a ceiling tile. If you saw the stain, you kind of knew where to start figuring out where the leak is. But if you didn't have it, where do you start? It can be a very iterative, intensive process to try to track down a leak. But now the equipment's going to have a leak detector. So if we have a leak, now we know where to start. But the really great thing too is if that fan coil over there senses a leak, it's going to shut that fan coil off and the rest of the system can keep running. So not only do we have a place to start looking for that leak, but we can keep the system running. So, I mean, how beautiful is that, right?
Right, right. Let's turn to the engineering side. From an engineer's perspective, what are the most significant challenges or opportunities presented by the A2L refrigerant shift for these VRF systems?
Yeah, I would say that there are challenges, but these are hurdles that we can clear, right? We've got ways of clearing them. So off the top of my head, one of the big ones was it was initially a gray area, right? How do we think of branch controllers? And the way the verbiage is it's gray, but it kind of seemed like it was, oh, that's continuous piping. That's part of the piping. An interpretation was issued late spring, early summer, I think. And ASHRAE's response was branch controllers aren't in that category. They're more in this category, meaning you've got to do a calculation for the branch controller. All right. So that means we got to be careful where we put branch controllers. We're going to have to look at doing ventilated enclosures, tying them into the airstream somehow, just making sure we have enough dispersal volume around that unit. So it's a slight hiccup. It was a little bit of a disappointing interpretation response, but like I said, we've got ways around it. The other challenge that it's still ongoing is the refrigerant pipe shafts. So earlier this year, they granted an exemption for requiring a shaft if you test it according to their standards. So that was a nice little provision for engineers, right? To not have to do a shaft, because when the shafts are required, or if you do have a shaft, you still have to ventilate it. So, opening it up so that you've got inlet air, outlet air, so that if it does leak, the refrigerant has somewhere to go and doesn't just build up, inside of that shaft. Now there is a proposal to remove the ventilation requirement. It's still being debated. It may pass, it may not pass. It's a coin toss at this point, but even the requirements for ventilation aren't that bad. It's a 4-inch outlet at the bottom of the shaft, opening to the outside with an inlet at the top. Really not too bad as far as implementing that requirement. I think one of the biggest challenges for everyone in the design world right now is actually the code. And the reason I say that is the code and ASHRAE, again, ASHRAE is the tip of the spear. They're not aligned because ASHRAE comes out 3 years before it makes it into code. All right. So engineers discussing this with code officials, so that code official, like, you're not going to get an engineer who's saying, I'm designing to an old safety standard. All right. Like, could they technically do that? Sure. But you want to go by the newest safety standard. You want to be safe with these things. So there's a lot happening over here that code officials may not be aware of. And actually, I've got a funny story. I was just talking to an engineer last week about it. And the code official, through no fault of his or her own, saw that they had an A2L system in the building, and they were like, hey, this, we don't have any provisions for this in the code. Like, you can't do this. And, of course, the engineer sitting there, he's like, well, we can't get anything else in the building. Like, so are you telling me we can't install HVAC in this county for the next 3 years? Like, no, of course not. And so keeping the conversations going with code officials so that they know what we're doing to ensure occupant safety. So those are the main challenges, I think. Now, lots of opportunities. Sticking with the code piece, one of the options you can do is, if something's not in the code, right? If I'm in a municipality that has IMC 2021, but I'm trying to cite ASHRAE 15, that's 2024, you can cite future code by filing a variance. You can say, hey, this is going to be in the code, right? This is a future code year. So you can file a variance citing that, because IMC 2027 will reference ASHRAE 15 2024, which is the latest one that we're on. Some other opportunities, of course, leak detection, mitigation controls, like I was mentioning before. The refrigerants are lower GWP. That's the whole reason for this transition. And a nice other little benefit that was kind of coincidental, I didn't really think about it until recently, was if you have to do, all these volume calculations for VRF, and you've got a branch controller that's handling all of the system charge in it, and you got to mitigate that or have enough volume for it, lower tonnages could benefit you. And a nice little side benefit to that is that the lower tonnages, and I'm pretty sure this is across all manufacturers, but the lower tonnages have higher efficiency and higher heating output per ton, right? So you're getting a lot more out of a smaller system. And so, like, a nice little side benefit is designing around smaller systems. You can get more out of your equipment, efficiency wise, heating wise, electrification wise.
Well, are there any applications or building types where the requirements may differ for A2L refrigerants and VRF, Joe?
Yes. And if you get to talk to engineers who do a lot of these, it can be very challenging. So the main classification is called institutional buildings. This is where the requirements differ greatly for engineers. So institutional is classified as any building or portion of the building where the occupants cannot exit readily without assistance. So some examples, to name a few: nursing homes, hospitals, prisons, sometimes daycares. And that makes sense, right? You have to assist these people to leave the building. So the safety standard says a few things. One, you have to have leak detection. All right, VRF, you're probably having leak detection anyway, so that's not a big deal. Two, you can't use safety shutoff valves or mitigation controls as a means of compliance. So you can put them in there, but it doesn't help you towards your ASHRAE 15 calculations for volume dispersal. The other hiccup with those is that if I have an office building where I'm allowed X pounds per 1,000 cubic feet, institutional, that gets cut in half. So you're really restricted on institutional applications with these A2L refrigerants, and rightly so, right? ASHRAE's throwing more than another safety factor on top of it. So as far as how to tackle that, ducted air distribution systems are a really great option. You want to connect spaces either through ductwork, natural ventilation openings, things like that. Now, we work with owners, we work with architects, that might not be feasible. And so another great option is the Mitsubishi hybrid VRF system, which was invented for this transition, right? We want to do VRF, we want to do A2Ls, but we want to keep refrigerant out of the space. So how do we get a VRF system, but have hydronic, have water serving the occupants of the building? And hybrid VRF is a really, really great solution for that. I get to keep my refrigerant between my outdoor unit and my BC, and then all the zones are served by water, because what's the ASHRAE 15 allowance for water? Infinite. We can have as much water in the space as we want, right? Because it's not gonna kill anybody. So hybrid VRF is a really, really great tool to have in the tool belt for tackling these new requirements with A2Ls in institutional as well as other buildings as well.
Well, it sounds like there's really a lot to know here, Joe. So gotta ask the question, for engineers who are just starting to specify A2L based VRF systems, are there resources, training, industry guidance? I mean, what's out there? And then what additional support will help with this transition?
Yeah, I'd say first and foremost that it's a conversation. ASHRAE is an organization. You can join ASHRAE, join your local chapter, discuss it with other people in the industry. And that's one of the benefits I've had is I get to talk to these engineers in both Maryland and Pennsylvania. How are you guys handling it? What questions are you guys getting from your code officials? What projects are you trying to do? And I keep getting new ways of thinking about it, new interpretations of this, that, or the other thing. So primarily keeping the conversation going. Also reaching out to, so Trane, we have a slide deck that I created, I've shared with a bunch of people, and we're still refining it, but you can reach out to your Trane account manager. They can give it to you as like a lunch and learn presentation. It's just the basics of ASHRAE 15 and VRF, how to make them work. And Trane, we have a couple webinars on our site that we've hosted through other publications in the past that cover the basics. And then lastly, I'd say ashrae.org. They publish, you can read the standard for free on ASHRAE's site. You can read the addenda that get posted, that get the official approval. The interpretations are up there. And so between that and continuing the conversation, I would say that's the best way to get a handle on this. And something to keep in mind, especially for like newer engineers, it may seem daunting and like a bit much to handle, and it might kind of turn you off a little bit, like, oh, this is too complicated for me. But it's a really cool time to be alive, because I mean, we've been talking about chillers for 100 years, right? So anything that changes with chillers, like it's like this much, right? We all kind of understand what's going on already. But A2Ls with VRF, like that, this is like 3 years old, and it's only 3 years old because actually started talking about it 3 years ago, and it's, you know, constant changes, but it's just because we're in the early innings of this thing. So it's an exciting time to be alive, and it might seem like a headache, but it's still a lot of fun. And if you work with everyone else in the industry, it'll be something fun to do together.
Well, that's great information. Thank you so much for your time today, Joe.
Yeah, absolutely. Thanks for having me. I hope it was digestible. I hope it wasn't too much. But yeah, I hope this benefits anyone who watches.
Excellent. Well, I appreciate it. And I've been chatting with Joseph Guerin from Trane. If you'd like more information about HVAC or VRF systems, please visit Consulting Specifying Engineer at www.cscmag.com. Thanks so much, and we'll catch you next time. Bye-bye.